case you could not see, I am blowing on this, and that is what's making it rise.
Ashley is putting the digital import into the DHT11 temperature sensor. She's put it into UNO, and now she's putting in the ground clip, connecting it to the DHT UNO board. And then this pin is the 5 volts power.
So the DHT11, it collects both temperature and humidity, and it sends that data through its import pin into our digital sensors. Alas, we have a Mateo in the wild.
So we're using the DHT11 sensor, which is like a low-cost digital sensor that measures the temperature and humidity. It operates using 3 pins: the VCC power input, GND ground, and data for the signal output. It's capable of measuring temperatures between 0 and 50 Celsius with the accuracy of +2 Celsius, making it suitable for basic environment monitoring applications like controlling the climate environment. The plan for the measurement is we're going to power the sensor, connect the VCC pin of the DHT11 to the 5 volt output on the Arduino UNO, and connect the DND pin to the ground on the board to provide the sensor with power. We're going to capture the data that the DHT11 sends the temperature and humidity readings to the Arduino UNO. This pin will be connected to additional pin 7 on the Arduino reading output signal. The UNO will be programmed using the DHT library to read the data from the sensor. It will process the data and calculate the temperature for both Celsius and Fahrenheit. Then we will output the results. The readings will be displayed on the serial monitor of the IDE, where the temperature will be updated continuously, allowing us to monitor any changes in the environment.
At the start of the code, you have to import the DHT library, which essentially includes all of the code for this guy. And within that library, there are different types of DHT sensors, like the DHT22, and this one specifically is the 11, which is why you specify that in the next line. Down here, you're just initializing that it's going to start collecting its data, and it's just kind of like a setup for the sensor. There's a delay because this sensor can be up to 2 seconds behind, and if it's just constantly spewing out data, it's not going to be very accurate. It'll also get really hard to read in the monitor. Down here, I'm defining all of the variables it's going to collect. The humidity float we're not using yet, that's a setup for next week's sensor, but the temperature is for this week. This is a print statement in case it fails. It just helps clean things up in case there's an error. And then down here, it's going to print all of these values in the serial monitor. And so it's going to print temperature, the value of the temperature, and it's going to convert it into Celsius and Fahrenheit. Print a new line, and then collect the next round again. Okay, so fun things were happening with this one. Essentially, I had the wires backwards, so the ground and 5 volts were going into the wrong pins, which was causing this thing to overheat to like a burning degree, and it almost broke the UNO. Fixed it, we're good. Flipped the pins. Second issue, up in the code, you have to import the DHT library, but thanks to the wonders of school Wi-Fi and everything that they block, if you go to include library, manage libraries, it blocks every single library within the Arduino IDE. So the only way to get around that is to go to, you have to essentially search for the Arduino library online, type in DHT, and then go to this sensor library to import it off of the Arduino library list. Long loop, but it got the job done. Got our temperature sensor working. So here's the DHT11, and the Arduino UNO, not really Arduino, but same purpose. So this is the digital pin. It feeds into 7, though it doesn't actually matter which one, you just have to specify in the code where the UNO is going to be receiving the signal from. And that connects to the output pin for the sensor. And then the other two, very standard for any circuit, you've got the ground and the 5 volts, which feed to the corresponding ground and VCC pins on the sensor. Then the code was explained already, but here is another example of the serial monitor. So there's where it's initializing and its first temperature. And if I breathe on the temperature sensor, you'll notice it starts to increase with a 2-second delay because this sensor is very slow.
It's going.
Wait, what?
It's going.
In our project, we will be measuring temperature of the biome on Mars and our enclosures for crops and human life, as temperature is crucial for plant growth and water management.
We are going to be measuring temperature on Mars because having the right temperature for our biomes creates healthy crops. Also, having healthy crops, that allows us to be healthy and live off something. So that's why temperature matters on Mars, and that's why we will be testing that. This project went really good, better than you would think, because we worked on an actual hands-on kit, which everyone didn't have. Ashley brought it in, but one thing that we did notice that Ashley talked about in the beginning, the wires were on mistakenly in different spots, and that caused the UNO to heat up, and it started to burn, and that could have broke the UNO, and that would have been really bad because we can't use it. Also, Ashley also talked about, again, our school. They blocked anything and everything, so it was challenging to get to our Arduino library, but Ashley found a website, so that's how it was fixed, and we can still use our script. But on my end, I have been sick a lot recently, and me being the media manager, this project I had to do a lot with recording, and me not being there really brought down the group. But my group stepped in, they recorded videos. Ashley would send me videos so I can edit little pieces, but fully Mateo and Ashley edit the videos and upload it so we could have our thing done on time. But I'm gonna submit this just a day later, so I still have my part in it, and I don't want to let my team down. So, narration. So this project we learned about precise sensor collaboration, and also working on a week timing with our DH10, learning everything, how to get our project good. But our project was also hands-on, so this challenged our group with different obstacles and figuring out how to work on our mistakes together. Although our project ran really smoothly, we learned how to use software and hardware needs to get our requirements that Mr. Bot gave us.